Okay, hi everyone. It says that we're live, which means in about 15 seconds you will be able to start responding and so forth. I'm really excited that so many people have decided to join me. Oh, I think I wanted to share my screen. How do I do that? How do I do that? It's one of these buttons, screen share. Okay, let's see which one we're gonna do. We're gonna do this one. Glunk. Watch this. Hey, there we go. Present to everyone. That's what I want. Yeah, isn't that what I want? I think so. You are screen sharing and presenting to everyone. So Google tells me. Breakfast with Ruben. Oh, you're so funny, Graham. I assume that's how you pronounce your name. You assume that I actually have time for breakfast. Actually, it's about 10 p.m. here in Israel, and for totally, it's a total coincidence. But basically, my wife is currently abroad, and my children are all out. So I have the entire house to myself, and yet, here I am in my office, as opposed to downstairs or somewhere else a little fancier. Let's move the microphone a little closer here, so hopefully you can all hear me better. So I'm really glad that everyone's able to make it, and hopefully more will come and see it on YouTube and so forth. Anyway, so this is going to take, well, we'll see exactly how long it takes. I'm guessing about 40 minutes, maybe 45 minutes to go through a presentation. Obviously, if you have questions, comments along the way, the whole Google Hangouts 15-second delay means that it might be a little weird. If you have a question, it'll take me 15, 20 seconds to see it, but we can try that. And we'll see how it works. So ask me questions along the way in the chat. And obviously afterwards, if there are more questions, I will be happy to answer them. Okay, let's see if I can find my presentation. Oh, I wanted to fire up IPython Notebook as well. Let's see. And what I did last time I did one of these webinars, I've started using IPython Notebook in all of my teaching, and I find it's just incredibly useful because it means that I can do all sorts of live coding and live demos, and then afterwards I can send the file to anyone who wants to replay it or go through it. It used to be that I would use regular old IPython and text, but to give people the history of IPython text version is really not very nice. So this is definitely superior. So let's fire this up and bring this into the main screen. Glunk, which hopefully you're all seeing, as opposed to the boring one over there. There we go. And unfortunately, like the screen only has so much room in it. So we're gonna have, I'll shrink me a little bit. You have to see me as much. Let's get more text in there, and it won't let me shrink it anymore. I'm as small as I can get, so I'm just gonna move myself over to the side there. And then, hello world. So clever, so clever. Okay, folks. So what I wanted to talk to you about tonight is Python's magic methods. And basically, everyone who starts to, I'm going to move the slides over here so you can see them as well. Let's see if I can hide things to make it a little easier. I'm sure there's a way to do that, but we're not going to do that just yet. We're just going to show you the raw stuff because I don't really use speaker notes anyway. Okay, so the thing is, just about everyone, let's start this way. Just about everyone who starts to program with Python and starts to use object methods learns a little bit about these funny methods, these ones that start with and end with the double underscore, or as they're known in the Python world with dunder. I must admit that I actually had never heard this before, never read it before until about, I guess, 2 or 3 years ago. I was listening to a talk or watching a talk, and I saw that someone was mentioning dunder, and I was sure I had misheard them. But no, it turns out that I just missed a piece of the Python terminology for all these years. So dunder is the double underscore. It means, before and after. And so we have all these different methods that we define, right? And so here's the way it works, right? We define our methods on a class. And I went through this a little bit last time with the webinar, right? We define methods on a class, and then we're going to invoke them via an instance. Now we're going to ignore for now, I'll put myself back here a little bit. We're going to ignore the static and the class methods that we might be defining. So those are a slightly different kettle of fish. We're still defining methods on the class, but we're not invoking them through an instance there. So some of the, the magic doesn't happen. But what happens then is it's all done through attribute lookup. And attributes are really the key to all this stuff, right? So I'm going to say class, foo. And if I say here, def init self and x, and I say here, self.x equals, well, let's say x, right? So, yeah, fine. So if I do that now, when I say f equals foo, so I've created my new instance of foo, and everything is great there, and I can say f of x. And what's going to happen is I'm going to get back 10. Now, why am I going to get back 10? Because Python is going to turn to my object f. It's going to say, hey, do you have an attribute named x? And if it does, which it does, it's going to return that value. But if it doesn't, then it's going to turn to the class, because the way in which attributes are resolved is always we go to the object, then we go to the object's class. Oops, sorry about that. And, yikes, that was not what I intended. Undo to the rescue. And then we go to the object superclass and so on and so forth. So basically what's going to happen then is anytime we're going to look up an object, or every time we're going to look up an attribute, it's going to go through this hierarchy. What this means then is when we create our objects, or when we create our objects, any methods that we don't define sort of come to us automatically. So, if I say now, show me f, show me the printed representation of f. Let's do this here. Okay. Printed representation of f, we're going to see that printed representation. Now, who defined that? Well, that was defined by object, by the original sort of highest level object class, which is going to then define a stir method. And we're going to talk about that a little bit as well. So basically what this means, that'd be a way to move this thing out of the way. Sorry, guys. Anyway, the thing is, these methods, we can use whatever method names we want, but there are a bunch of these magic, I'm going to just move the slides off. I'm just going to talk. You don't need to see the slides. I can mail them to you later. I'm sorry. So the thing is, we can call our methods whatever we want. But if we use these special methods, the dunder methods, right, ones with underscore and the double underscore in the front and the back, we're not really supposed to invoke them ourselves. We never invoke init, right? Init is invoked for us when we create a new instance of our object. And we never invoke stir either, right? So if I say class foo object, and then I say here, def init self x equals x, and then I say def stir. Right? We went through a little bit of this last time as well, I think. Return my x is this. And so now if I say f is a foo of 10, and now I can, oops, don't do that. And I say, just f, give me the representation. Oh, sorry, stir. I should have said repper. Let's try this again. Repper. In that, oh my goodness, turn self.x. Self.spell it correctly, x. Live coding, folks, never do it, never do it. Okay. Anyway, so what's going to happen here is you see that my printed representation has been replaced. So we have now basically overwritten repper, but we're not going to invoke repper directly. I can say stir of x. I can even say stir of f. One of these days I'll remember. Stir of f. I can say, repper even of f. To give me that. But I'm never going to call, I'm not supposed to call f.repper, even though I can. But you're really not supposed to do that. Okay, so those are like some of the initial magic methods that people are exposed to when they start working with Python. The thing is, there are a bunch of additional ones that are defined in Python that sort of make the language richer, more interesting, more complete. And the more of these you learn, the more, as far as I'm concerned, you understand the language and you're sort of impressed by the language and its elegance. You don't need to know all of them. You don't need to know most of them. You don't need to use most of them. But sometimes they're going to come in handy because they allow you to be more expressive and they allow your objects, the classes that you create, to work just like the other objects in Python. They fit the paradigms, they fit the protocols that have been defined. Okay, so let's start with the first easiest one, which is len. So a lot of people, especially like I do a lot of work in Ruby as well, and so in Ruby every object has a length method that you can call on it, or size method you can call on it. It gives you its size. And so many people are sort of frustrated in the object-oriented world that if I say here, s equals ABC, I should be able to say s.length. But of course, that's not going to happen in Python. And that doesn't happen for a variety of reasons. I think most of it is just history. But len is this global function, or built-in function, I should say, that returns the length of something. So if I say len of s, it's going to return 3, not surprisingly. Now, what's really happening? Len goes and it looks for the method under len under. So if I say class foo object, and now I say def, init. Actually, let's just do this. Let's just say pass. And now I'm going to say f equals foo. And I'm going to say, what's the len of f? And Python's going to give me an error. It's going to say it has no len. Now, it's sort of unfortunate it gives, at least in Python 2, this sort of error message, because not that foo has no len, it's that the under len under method has not been defined. So let's go back and modify our method, modify our class. Let's say def len self, because we're always going to get self, and now let's just return 5. And now, see what happens? Now it has a len. Len is always looking for that method, and you can define that method to do whatever you want. Right now, I've got this ridiculous class, of course, and every one of the instances of this class is going to return 5 for the length. Not exactly earth-shattering stuff, but definitely something that could be interesting. But you can, of course, define to be whatever you want. And I've got an example. I'll just pull. Oh, you know what? Here, let's just try to pop it in to IPython notebook. A little cut and paste magic. All right, so I've created a book class. And so my book class has an init where it takes a title, an author, and a number of pages. And it's going to do the standard self-title, self-author, self-number of pages. Well, now I'm going to define length to return the number of pages. Now, I could, of course, have used it to calculate something. I could do all sorts of things. In this particular case, though, I want the len to represent a particular object that is within my book object, in this case, an integer. Okay, so far so good. But again, this is sort of basic stuff. The magic methods go way beyond that, and they provide us with all sorts of really cool things that we can do. And I would argue, in fact, that sort of the future of Python is in these magic methods. Every new thing that's happening, we're not going to have time tonight to talk about, even the stuff that, basically everything you want to do in the new versions of Python, whether it be iterators or generators or decorators or, meta classes or context managers, all the new stuff takes place in magic methods. And what happens basically is new versions of Python define new magic methods that you can use in new and interesting and different ways to keep track of what's happening. Okay, so let's start with a first one here. Let's talk about add. And some of you might be familiar with this. So if I say here class, let's first start off with something like this. This is something I only noticed in the last year or so. If I say 1 plus 1, it probably won't surprise you to discover that I get 2. Yeah, good, right? Python's pretty good at that. And if I say 1 plus 1 here, 2 strings, then I get, well, the string 1, 1. But of course, if I say 1 plus 1, it's going to say, I'm sorry, that's not okay. And look very carefully at this error message. Unsupported operand types for plus, int and stir. Okay, so far it's an error message, not that exciting. But if I say 1 string plus 1 int, meaning I'm going to reverse them, we're going to see that I get a different error message. And that's because the order in which the operands are given is significant. What's happening is that Python is looking at the first one, the one on the left, and it's then using that to determine which method is going to be invoked. So in the first case, it's more or less saying, I'm going to use the int version of add, and I'm going to use the int version of add on 1, and I'm going to give it as a second parameter, as a second operand, the string 1, and that gives us the error. In this case, it's going to use the string version of add, and it's going to add to it the int version. It's going to add the int version of 1. So this means that when we add, what's happening is this. When I use plus on something, when I use plus on one of my objects, plus is looking to the left and will invoke add on that. What do I mean by that? Let's do this, class foo. By the way, we're going to use a lot of class foo tonight. Hope you don't take class foo, everyone. Def init self x equals x. So far, so good. And I'm going to say def add self and other. Okay, and now what? Well, now I'm going to assume for the time being that other is also an instance of foo. So all I really have to do is say return self.x plus other.x, right? And so now if I say f1 is foo 10 and f2 is foo 20, and I say f1 plus f2, well, that's going to return 30, right? It's going to give me the combination of adding them. Okay, so far not too exciting, not too surprising. The thing is, maybe I don't want to do that. Maybe what I really want to do is create a new foo object. Because when I add A and B, it's not returning 2. It's not returning the length of them. It's returning a new string object, AB. So really what maybe I want to be doing is this. Return foo of self x and other x. Right? And so now we're going to have a new foo object that comes back. Yeah, but what's the value of that foo object? That would be kind of nice to know, wouldn't it? Well, let's try this. Def repr of self return my x is. And now you see when we have f1 foo 10, f2 foo 20, we add them together, we're getting a new instance of foo, and its representation says my x is, and we see that the x actually is the value, or self.x is the value of combining those two previous ones. Not too shabby, not too shabby. The thing is, once again, we're looking here on the left. So we're assuming that the one on the left, f1, is being invoked here. As I say, plus is invoking add on F1. Now, in this particular case, F1 and F2 are both of the same type. But here, let's try this. What if I say F1 plus A? Well, now our method is going to go totally nuts, right? Because what is it doing? It's trying to find the X attribute on the string A. And as it tells us, the stir object has no attribute X. Well, that's sort of a problem, isn't it? Well, so what can we do? Well, there are a few things that we could do. First of them is to say, we can make add a little more flexible, right? We can try something like this. I'm not sure if I really would do this, but it's not a bad thing to necessarily try if you're stuck. I can say add if other, or I can say if has adder. And has adder is a built-in function that lets us probe an object to see if it has an attribute. So if has adder other X, then we're going to do this. Otherwise, we're going to say return, well, what am I going to do then, right? If it has an X, I'm going to return that. Otherwise, I'm going to say return of, let's say foo of self.x plus other. Let's hope that that other object will then be able to do it. So in this particular case now, our X is still 30. That's good for now. What if I say F1 plus 100? Well, now it's going to say my X is 110 because what did it do? It saw that our integer did not have an X attribute. And so it created a new foo instance, not based on self X and other X, but self X and other. Again, is this the right way to do things? Well, it depends on what your objects are doing and how you want them to work. Maybe. Certainly, it's not totally crazy, and you see how it's super easy to go in and change this in the code. But there's another situation that we can be in, which is sort of interesting and unusual in Python. What if I say here F1 plus 10? Well, that works okay, right? But what if I say 10 plus F1? Now we're in that same situation we saw before, where if we flop the order of the operands, we're going to get now, right, unsupported operand type for plus, int, and foo. So it's saying, listen, the int version of add is not smart enough to know what to do with your foo object. I'm sorry, it's just not going to happen. So what can we do in this case? It might seem that all is lost. It might seem that everything is hopeless. But no, Python actually has this really cool idea. We not only have add, we have reverse add. Yes, indeed, folks. Watch this. This is super cool. Def, well, I mean, if you're into this kind of thing, right? Add. And reverse add, here's what happens. We go, or Python goes to int. It goes to the int, and it says, hey, I've got a deal for you. We're going to add you, Mr. int 10, with this F1. What do you think? And the int returns, it was actually a constant in Python, which is not implemented, meaning no way, I cannot do that. If the plus operator gets not implemented from doing 10 plus F1, it flips them and then invokes our add on our object. So we're going to see now is we're going to say our add, and it's going to take self and other. Right? And now what are we going to do? Well, we could just re-implement all of add, or we could just say return self add. Here we are invoking explicitly. I guess we use plus instead too, but it seems better to use this. And we're going to say with other. Now if we do it, right, we can say F1 plus 100, or we can say 100 plus F1, and that will still work. I gotta say, I think that's just super snazzy, but I'm easily impressed. Here's another thing that you might not know. So when we say plus equals, right? So if I say X equals 100, say X plus equals 200, we might think that this is exactly the same as saying X equals X plus 200, and the effect is generally the same. But actually, two different methods are being invoked here. The first one, when we just say X equals X plus, right? Here we're invoking the add method, which we've just seen. But here we're invoking the iadd method. And the iadd method is basically the in-place add. This is what's invoked if we add something to itself. So in that particular case here, let's add this to our foo definition. Def iadd self and other. Now the thing is, the difference between iadd and add is that add should be returning a new object, whereas iadd should be modifying our left-hand object and then returning itself. So now what we're going to do is we're going to say, let's just assume we can add the darn thing. Okay, let's not get complicated. Self.x plus equals. Here we're going to use plus equals inside, right? Self.x plus equals other.x. We're going to assume that works. Then we're going to say return self. If I do that, now I can say, watch this, print F1. There are a few Python free people out there. Print F1, and I'm going to say F1 plus equals F2, and I'm going to say print F1 again. And now I've not created a new one. I've actually modified, as you can see, F1. So I add, R add, and add are all totally different methods, and they allow us to really break down how we want to add things together and to play with them. By the way, something that I just found out about recently, which I think is somewhere between cool and disturbing, is that if I define a tuple to be a list, 1, 2, 3, right? Now let's say 4, 5, 6. So we know that we can modify these tuples, right? I can say t.0.append, t.0.append 4, right? And now if I look at t, my tuple, I can modify that list that's pointed to by tuple. Yeah, that's totally reasonable. So you would think that I can also say t of 0 plus equals, let's say 9, 8, 7, right? Because all I'm doing is I'm modifying that list. I'm using the I add on list. And yet I get this bizarre behavior. I cannot explain it, but it also happens with Python 3. Tuple does not support item assignment. So first of all, it's like, huh? Really? I'm not trying to change the tuple. I'm just trying to change the list that's within the tuple. But secondly, let's see, watch what happens here. Let's look at our tuple. It actually did change, which in my opinion is like the worst of all possible worlds. We get an error message and the change actually happened. So boys and girls, the lesson is don't use plus equal on lists inside of tuples. And if you're doing that anyway, you've got bigger problems than that. Okay, by the way, I don't see any questions, so I'm hoping that people are actually seeing me and hearing me. Let's hope. Anyway, if not, this is gonna be a real private chat. Okay, let's take a look at some other interesting methods we can look at. What else do I have on my little list here besides, type conversions. Well, these are fairly simple and straightforward. And then we're gonna get to the like really meaty cool stuff, as if this weren't cool already. So let's say I say, class foo object. And now I say f equals foo. So if f is equals foo, is f true or is f false? Well, I can find out. I can say bool of f. And that says true. Well, that's because everything in true in Python except for 0 and empty sequences and mapping. So like if it's empty, it's 0. Or I'm sorry, if it's empty or if it's 0, oh good. If it's empty, then we can it's considered false. Otherwise, it's considered true. So, but that sort of doesn't make sense in the case of some objects. What if I want my object to be considered false? Well, I can just define. Let's do def init self x equals x. All right, and I'm going to say def non-zero. I'm going to say return, let's say bool. I'm going to turn it into a Boolean self.x. So now I can say f equals foo. Let's make that ABC. And we know that ABC is considered true in a Boolean context. So now if I say bool of f, it's going to say true. Well, that's good. But if I say f equals foo of 0, and I say bool of f, voila, we've now made our object true or false depending on one of its attributes, which is kind of neat and kind of useful. Now you should know that in Python 3 they've changed this non-zero. Obviously, this had to do with not only booleans, but like booleans as 0 or non-zero. In Python 3, it has been changed to be bool under bool under, which matches also our intention of turning it into a boolean. We can do this with ints also. We can have an int method, which, by the way, is a problem just because it's really easy for newcomers to mistake init and int. Other than that, it's pretty straightforward. If you want to turn your object into an int, you've got int, you've got stir, you've got hex, you've got a lot of these different methods that do that sort of thing. Okay, let's talk about something a little meatier here. Let's talk about string formatting. So the old way, and the sort of traditional way that we would do string formatting and string interpolation in Python, well, you can't really do interpolation, right? You can't change the string because strings are immutable. So instead what we're going to do is we're going to say, ABC, send S, DEF. And then we're going to use the percent operator, which is usually modulus in math, right? But here we're applying it to a string. And as we've seen, we can apply whatever method we want on whatever object we want, whatever operator we want. So here all they did was they applied, I believe it's the mod under operator to string, which obviously they did not write in Python, they wrote in C. And so now if I say, I don't know, y here. So what's happening? So this percent here is looking to the left. It sees a string. It says, aha, but in the string, I have a percent %s. So it looks to the right, and it then includes that. Now, there are all sorts of problems with this sort of string formatting. And they're not obvious at first, but little by little, you really get bitten by them. So for instance, here's like a simple one. Let's say, it's a well-known sales technique that you should use someone's name as often as possible when speaking with them. So, we want to do something like this. Hello. Yes. How how are you today, %S. Right? So like we've got a string here for salespeople. And now I'm going to add my name in here. Well, that's a problem because I only put my name in once and it's expecting 2 of them. Now, never mind the fact that I need to actually put a tuple here. What's really annoying is I have to actually list my name twice and then it'll work. And wouldn't it be nice to just say, hey, I just have, let's just use my name once. Well, in order to do that, we have to use a different kind of string formatting, and that's what we call stir format. And it's a new method, relatively new. It's been around for a few years already. And we're going to change things around. I don't want to go into all the intricacies of stir format, although maybe we can do that another time. Okay, and we're going to 0. And now what I can do is I'm going to apply a method. And the method here format takes a variety of different kinds of parameters. If we just use regular old parameters, then what happens here is we have one parameter, so it gets indexed 0. And then inside the curly braces, we can say curly braces 0 and curly braces 0, and it refers to the same parameter twice. And so now if I evaluate this string, it will very nicely annoy me as a sort of kind of salesperson might do. And again, there are lots of parameters for this. Where things get interesting, I think, is that we can provide formatting options to these. So inside of the curly braces, after the 0, I can say now, colon, let's say 15. Right, and here I'm going to say colon 15 also. And now it's going to pad that with spaces. Okay, well, what if I don't want it to be left justified? Here, let's make this one left justified. So we can either leave it the way it is or we can make it less than. And here we can either, we got to use the greater than sign. And by the way, you can use a caret above the 6 to center it. So now you can see that we've told it, here I want the 0th item, and I want to be formatted so that it's left justified in a field of 15. I want to be right justified in a field of 15. By the way, it is sort of a problem that the formatting codes are sui generis. They were developed just for Python, and they're from no other language or system. Oh well, it's not that hard to learn, and there's actually a relatively new website called pyformat.info. Definitely worth taking a look at. That's really worth taking a look at, where they have lots and lots of information about these formatting codes in a way that's actually easy to understand, because I can assure you that if you read the PEP or if you read the documentation, you will not understand it unless you spend a lot of time on it. How do I know this? I spent a lot of time on it. Okay, well, here's the interesting thing. What if I want to create an object and I want it to be formatted in different ways? It turns out that this is trivially easy to deal with. And the reason is that when our object is being formatted, the format method, stir format, invokes our object's, surprise, surprise, magic format method, handing it this thing from after the colon there. So let's try something like this. So I do a lot of teaching. I mean, I live and work in Israel, but I go to China a fair amount, going there in 2 weeks. Woohoo! Anyway, very excited. So let's do class person. And you know that like one of these big things that's like clearly a cultural divide that I just always get wrong when I go there is I talk about first names and last names. And obviously in China it's flopped because people have like, for them last name. Anyway, so what we really should be using is a given name and surname or something like that. So let's do def init self. Let's say given and family. Okay, and so I'm going to say self given equals given, self family equals family. Okay, so now we have the person's 2 names. Now here's the thing. I want to be able to format it in different ways depending on where I am or depending on the person's interests. So now we can do this, def format for self. And now I'm going to get the format code, which is typically called format. And now I'm going to do something like this. Why am I going to do this? If the format is equal to, let's say, I don't know, given first. I'm going to say return, and I'm actually going to use format inside of here, which I think is kind of ironic and funny. Format, I'm going to say self given and self family. By the way, if you use the curly braces without anything in them, it just takes the items that you gave in the parameters one by one. I was told that it's actually nicer and better to do that, so I will listen to what I was told. Okay, so we return that. If the format equals family first, then we say return. Watch this. Well, we still do 0 and 1, right? There's a cleaner, nicer way to do this. Self-family, self-given. Do elif here. And then if I say else, return no good format. Okay. Unknown format code. Yes, this is not exactly what you want to do to people, but fine. And so I'm going to say p equals person. And now I'm going to say hello. I'm and we're going to put the like person there. Now, if I just said do that format P, we're going to get the result, hello, unknown format code, which is a greeting you don't want to hear. But I can also say 0, colon, given first, and now it'll give me my given name first. But I can also say colon, family first, and now it'll flop them. I think that's like nice and elegant, actually. Now, it means that you have to build up your own library of what are the codes that are acceptable. You'll need to tell people what they are. And if you want to do something a little fancier, like they did here with the different formatting and like greater than, less than, and padding, you'll need to take that apart yourself inside of your format method and figure out how you're going to pad, what you're going to use. But as a general rule, it means you're just given this text and now do with it what you will. Okay, so that's formatting. What else do we want to do? Let's talk about pickling a little bit. So pickle is this nice Python format for serializing, marshalling objects. And it's actually a number of different formats in the same family. It's been around for a long time. I'm just going to use like the simplest format now, even though it's textual and it's not the best, but it's more than good enough for our purposes tonight, for those of us for whom it's night. In any event, the idea of pickle is I can take an object and I can pickle it. I can turn into the serialized format, and then I can read it back and I'll have the object back. So if I say import pickle, and by the way, in Python 2 at least, they're both pickle and C pickle. And C pickle is written in C, surprise, surprise, and it's like 1,000 times faster apparently. So why don't we all use C pickle? Apparently there are cases when it can't handle it. And for demonstration purposes, I really don't care and I really don't think about it too much. I probably should, so let's use C pickle as pickle. All right. Oh, I need to use the capital P. There we go. Okay. So now I can do something like this. I can say D equals A1, B2, and C3. I've got my dictionary. Okay. And now I'm going to say pickle dump S D. And dump S means I want to get a string back. And you'll see this is how my dictionary has been stored. As I told you, it's a textual method. Well, I can store that into another variable, right? I can say P equals pickle dump S D. And now I've got a string. So now I can do the opposite. I can load it back. I can say my new D equals pickle load S from P. Now I'm going to load it back. And now new D is a new dictionary. It is not the same. If I look at the ID of new D, right, I've got a new dictionary as opposed to ID of D. So they're equal. New D equals D. Yes, they're going to be equal, or but they're not going to be the same object, which is pretty great. And you can use pickle to move objects across networks. You can save them to disk. There are some caveats, of course. Any class that uses built-in Python objects should be able to pickle just about everything, although some of them might not be useful. Like if you pickle a file, right, a file object, it's not going to really give you anything useful. You can't do that in the earliest version of pickle, but you can in later ones. Not that I'm sure what or how you would want to do that. And it's useful across networks. There's also another thing that you have to be careful of. If you load a pickled object and the class definition is not in your current memory, then you're in trouble. So here, dict, fine, dict is always defined. But let's say I have my foo object and I save it, using pickle, and I load it back in a new instance of Python where I've not yet defined my foo class. It won't work. It'll throw an error saying I don't know what this foo thing is. It knows it's supposed to be an instance of foo, but it's not how to deal with it. By the way, Noel, I see your question about formatting. We'll get back to that in a little bit. But thank you, and I really like getting the questions. So, so pickle is like super useful in these ways. The thing is, we can like basically customize pickling to some degree, and I just want to show you a little bit of what we can do with that. We're going to say class foo object back to foo, right? And we're going to say def init self x, and we're going to say self x equals x. So far, so good. We have our standard object which has x on it. Okay. Now here's the thing. When we pickle our object, what are we really doing? We're taking all the vars of the object. We're taking all the attributes that we've defined on the object, and we want to store them. And they're going to come to us as a dictionary. Which dictionary? The vars dictionary. The dictionary that every object has, that every instance has, every object has, I guess. So what's going to happen is when we pickle our object, the getState method is going to be invoked. And by the way, when I say getState, that's because the under at the beginning and end are silent. So getState. Now we're going to be basically given self. I think it's just self. Let me just double check. Yeah, it's just self. Always want to double check these things. And now what? GetState is what pickle invokes to say, please give me the dictionary of names and values that I should be storing. So we can, if we return an empty dictionary, then none of our values will ever be stored. If we modify the dictionary, though, that we're given so that we can grab from self, we can return something else. So watch this. I can do something like this. I can say here, my current, or let's say old state equals self. And so self is our object. And we're going to say dict, which is the dictionary where everything is held. And we're going to say copy here. And the reason is, and the Python documentation even says this, you don't want to be messing with your actual object values, right? You want to be messing with a dictionary that's a copy of it, because you don't want to be changing the original object. So now I've got the old state. So now I'm going to say old state, let's say y equals self x times 2. So all I'm doing is I'm saying when I'm pickling this object, I want to add a new y attribute, and it's going to be equal to x times 2. So I'm going to say f equals foo, 10. F, oh, excuse me, I'm going to see it. Sorry about that. Google Hangouts, gotta love them. Okay, so now if I say, f.x, right, it's going to be 10. Well, here's the thing. If I now say new, or let's say p, this is going to make pickled object in, pickle dump s of f. By the way, vars of f is going to show me just x. So I'm going to say p equals pickle dump s of f. So far, so good. And now I'm going to say new f equals pickle load s from p. And now if I say vars of new f, oh no, that didn't work very well, did it? Because I forgot to return the actual dictionary. Return old state. That is indeed what we meant to do. And this, hey, and now it works. And one of my favorite parts of IPython is you can go in and modify cells and no one ever has to know that you made a mistake. Don't we, people? Anyway, so you can see here now that I've managed to add it. Now, why would you want to modify get state? Truth be told, it's not very frequent as far as I'm concerned, but let's say you have an object, let's say you have a file and you want to store the actual contents of the file, or you want to store a pointer to it, you want to store a URL. You want to do things that are being handled before pickling happens. And there's a similar one for set state when you're basically creating the object based on this dictionary. You can then read in all sorts of things and play with sorts of things. You can add those sorts of flags. I do want to read from the network. I don't want to read from the network. Here are my timeouts. You name it, and it's definitely possible. Okay, last topic I want to address is equality and hashing. So if I have two objects, let's say I have class foo again, right? Let's just say pass. Say f1 equals foo and f2 equals foo. And I'm going to say, is f1 equal to f2? And the answer is, of course, no, they are not. Now, you don't get objects that are much simpler than this. But the fact is that when Python compares objects with equal, it's really using the ID. It's saying, is ID of f1 and ID of f2? And I actually just read earlier tonight when I was doing a little research for this, the ID is the address in memory. So I always thought, oh, it's just some random number or something. But no, it's the actual address in memory, which means that if the two objects are distinct, they will have different values. Okay, so they're not equal, but we can make them equal. We can make them believe that they are equal. We can do this. We can say class foo object, and now let's add a little state here. Def init self x equals x. And now I can say def eq. Yes, under eq, under folks. And I'm going to say self and other. And I'm going to say return self.x equals other.x. And now I can say f1 equals foo of 10, and f2 equals foo of 10. And is f1 equal to f2? Yes, they are. But if I say f2 equals foo of 20, right, and f1 equals f2, it's going to say here, no, they're not. We can customize how we think things are equal. Yeah, but we can go beyond that. If two things are equal, they should also, maybe they're also hashable, and maybe they should be hashing to the same thing. Now, a lot of people, when they start working with Python, are told that you can only use immutable objects in your dictionary keys or in sets, right? So if I say here's my dictionary, D equals, and I want to use a list, 1, 2, 3, as my key, Python is not going to like that. It's going to say unhashable type list. And so we often think that something is mutable, it's unhashable, but that's not true. It turns out that it's true that all immutable types are hashable, but there are also mutable types that are hashable. For instance, this guy, pass. If I say a hash, I'll say f equals foo, I'm going to say hash of f. it will actually work. And what's it going to give back to me? It's going to give me actually the ID of the object. So strange as it seems, you cannot invoke the hash function or put in dictionary keys or in sets. You cannot do that to lists. You cannot do that to dictionaries, but you can do it to your own objects, which of course might have a list or might have a dictionary in them. So that's a pretty sneaky way to get around that issue. But what if you want to modify the hash function? Well, tonight's your lucky night, folks, because I'm going to show you how to do that. We can say class foo object and say def init self x equals x. And now I'm going to say def, of course, hash self. I'm going to say return the hash of self.x. So now if I say f equals foo of a, right? Now if I say hash of f, now it's going to be hashing f as if it were a. If I say f of foo is 1, the hash of f is, of course, 1, because all numbers in Python hash to themselves, except, of course, -1, which hashes to -2, and -2, which also hashes to -2. So don't use lots of -1s and -2s if you're worried about having hash collisions. Okay, so great. Now that I've defined this, I was always able to use my objects in a dictionary, but all right, why would I want to do this? Maybe there's some particular field that I know can be a primary key that I can use it for hashing. But actually, where I think this is interesting is it lets me create mischief and mayhem. What do I mean? Well, the whole reason that we have this idea of immutable and or hashable, I should say, in Python is that we don't want things to get lost in our dictionary. And when I say lost, I mean that I want to be able to look something up and know, hey, is this object in our dictionary? So if I say A in D in my dictionary from before, it'll say true. And why? Because it's going to invoke the hash function on A. It's going to jump to where the hash function says it should be in the table. And if it's there, great. And if not, not. Yeah, so we're going to get around that. We're going to do import random. And we're going to say class foo object. And we're going to say def hash self. And we're going to say now return random get randint, I think it's called, randint 10. Let's say 1 and 100. So now things get a little more interesting, right? So I'm going to say D equals my dict, and I'm going to use, well, I guess I need F equals foo. Do this, F equals foo. The hash of F is now 58, except now the hash of F is 19, except now the hash of F is 83. This is a fantastic thing to do to your friends when they go get a cup of coffee at work. Just sneak in, they'll never know. And then they'll be totally puzzled and you'll come in and save the day. I never said that. In any event, the thing is now, let's say I actually store something in my dictionary with this. So I'm going to say D equals F and 1. So can I actually get this out? If I say F in D, it's going to say no, it's not in there. And the reason it's going to say that it's not in there is simply because it's looking at the hash function. The hash function has made it disappear. The only way, once we've done this, is either just keep going, right, in a loop until we hopefully find it, which if we've got 100 random integers there, actually 101 random integers, it's going to take quite some time. Actually, it's 100. The other way to do it is just say D keys. And if I do D keys, then I'm going to get this list back. And then I will get the object despite the fact that it wasn't hashable. Or it was hashable, but that it was like purposely getting lost. Is this actually useful? I don't know. But I found it to be an interesting quirk that you can force Python to go against its principles of making sure that everything that's hashable is doing so in a sane way. And of course, the whole reason why we don't let mutable data structures be dictionary keys is we want to avoid precisely this. We want to avoid a situation in which their values are like going crazy on us and getting lost. I think that was basically it in terms of like formal stuff. So now I'm going to get back to the question that we were asked. If you overwrite your format method, can you still use the so the question, in case people didn't see, is if you overwrite your format method, can you still use the :15 formatting? And I don't think so. I don't see any way that would happen because you're getting the parameter and then you have to do something with it. Now, what you could do, of course, is break it apart and hand it back to someone else. So, I could say, let's go back to that example for a moment. Let's say, family first here. So if I got this here, what I could do, if I really wanted to, is like use split to break this apart. Like here it's equal, equal, and equal, equal, right? But I could say if I'm going to split it across colon, or I'm going to split it across tilde or something like that. And then I can say the first part is going to be the word, and the second part is going to be the the specifier. A while ago, I was convinced that you get a bunch of different things, and then you can address each of those. But that's not the case. You get one string, and then you have to interpret it yourself. If there are questions, I would love to answer them. Otherwise, I'll put up the promo slide. Here, you can ask questions. Those of you who don't know, you can follow me on Twitter. You can buy my book, which has less excitement, perhaps, than this webinar in terms of communications fun. Hangouts went dark. Oh my God. Did it now? Did it? All right, tell you what. Well, that's fantastic. That is just fantastic. See, can I screen share? Nope. Oh, you can see me now? Yeah. Okay, fine. Oh my God, this is like oh, there we go. Oh, but now it's like, anyway, I'm going to undo that so it doesn't like create all sorts of yikes. Oh, okay. Further questions, further comments, further insights. I find this stuff to be really fun and interesting, as you can tell. I think it's also useful to sort of understand how Python really tries to use these methods so that we can use the existing operators in fairly logical ways for our own objects, and have our objects sort of like keep working the same way as all the others. So you're just using plus, keep using plus. For a long time, I actually was not a big fan of operator overloading, but I actually think the way that Python does is pretty clever. And as I said before, we see more and more places where these magic methods are being used to extend Python. So, as I mentioned before, in terms of decorators, in terms of iterators, in terms of generators, but we also see new things that are in there as well. I was just about to say one, and I can't remember what it was. But there are many of them, and hopefully after we finish with the broadcast. Anyway, it sounds like there are no questions at this point. I would love to hear from you folks. I would love to hear suggestions for future topics. I want to do these about once a month. I'm probably going to be teaching a bunch of courses on NumPy and SciPy in the next month, so I think that may actually be the topic for next month, since I know that those are really popular topics, and it'll give me a chance to dive into them a little more and talk to people about them, and maybe even answer some questions you might have. If that's it, I'm going to stop the Hangout now, stop the broadcast. It will be on YouTube. You are more than welcome to share the links. I'll share the link on the list from Eventbrite and elsewhere. And thanks so much for everyone for participating. And I look forward to seeing you hopefully next month. And if you have ideas, again, for suggestions in any way, I'm always happy to hear from you. Thanks a lot. Good night from Israel. Good morning to those of you in New Zealand and elsewhere. And I will talk to you all soon, I hope.